Vapor pressure on the F160. We've previously seen that you can write the saturation vapor pressure as the equations that are shown: Rs by PD, that is the saturation mixing ratio by the pressure of the dry air, divided through by this factor epsilon, which is the ratio of specific gas constants or molecular weights, also written as the expression RSP all over Rs plus epsilon. But the saturation vapor pressure is much less than the total pressure in the atmosphere, and or this epsilon is typically much larger than the saturation mixing ratio, and so you can approximate the equation for the saturation vapor pressure as Rs on epsilon by P. Now in this equation, Rs is measured in kilograms per kilogram, which is inconvenient because typically in those units Rs is small, so we can rewrite this in terms of Rs dagger, which is Rs in grams per kilogram. And what we need to do is then divide through by 1000. And we know what epsilon is, and so we can write the saturation vapor pressure as the saturation mixing ratio in grams per kilogram multiplied by the pressure divided through by 622. And you can have the same expression for the vapor pressure, and it's just E is equal to R by P on 622. Now what this does is allows us to measure the vapor pressure on an F160 very easily. So take a profile where you've got a value of temperature, which gives you a corresponding mixing ratio for saturation, and a dew point temperature, which gives you the actual corresponding mixing ratio for a given pressure. And then lift the parcel of air isothermally from both those points until you cross the 622 isobar. At that point, R in grams per kilogram will give you the vapor pressure in hectopascals, and Rs in grams per kilogram will give you the saturation vapor pressure in hectopascals.